Solving quadratic equations. So we have a few different quadratic equations here. We're going to approach these with the quadratic formula and completing the square instead of factoring. Factoring works sometimes and it doesn't work others. On some of these factoring will work and on others it won't work. So for the first one here, I want to solve for z with 5z squared equals 245. Since there's only a z squared here, we're going to isolate it because it's the only z around. So to do so, we need to break that multiplication by dividing. 5 divided by 5 is 1. 1 times z squared is z squared. On the other side, I have to take 5 into 245, which you could do with long division or in a calculator. My calculator, 245 divided by 5 is 49. So now I know the right side is 49. To get rid of the square, we'll apply the opposite operation, which is square root. When you take the square root of a square of the variable, when you square something, you lose track of whether it was positive or negative, so we have to adjust the other side here by putting in a plus or minus. So anytime you have a square root on the outside and a square on the inside, you need a plus or minus. Square root of 49 is 7. So either z equals 7 or z equals negative 7. Now we should really check. So I think I have an answer. I'm going to circle it. I need to make sure it's true. Check. To check, you always plug back into the original equation. So I want to go into my 5z squared. I'll replace the z with a parentheses. And then I want to see if 7 is an answer. So is this a true equation? Well, 7 squared is 49. If you check on your calculator, 5 times 49, well, 5 times 4 is 200. 5 times 9 is 45, so yeah, that equals 245, and that checks. I also need to check negative 7, make sure that works. So again, you write down the original equation, replacing the variable with a parentheses. I'm hoping that whatever I plug in makes it true. So this time I'm going to plug in negative 7. Negative times a negative is a positive. 7 times 7 is 49. And we already know that 5 times 49 is 245, which is exactly what I want it to be, and so both check. So this is definitely the answer over here. So we have two answers. Next problem. 8x squared minus 22 equals 5. So in this case right here, I have a couple options. I could try to factor, I could use the quadratic formula, or I could use completing the square. I'm going to try the quadratic formula this time. Quadratic formula says if you have something that looks like a number times x squared plus some other number times x plus a third number with no x, and that's equal to 0, then x is always going to be equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I believe a is 8. I believe b is negative 22. And I believe c is 5. So plugging those in here, first I have the opposite of b. So the opposite of 22, or negative 22, is 22, right? Opposite of b is positive 22. Plus or minus the square root. Now I'm just going to write this down for now, and I'll clean it up in a minute. I'm going to have to take negative 22 and square it. Then I'm going to have to subtract 4 times a, which is 8, times b, which is 5. So I think we need the calculator for that. Oh, let's finish this actually. And also I need to divide everything by 2 times a. But before we can do anything else, we got to clean up what's inside that square root there. So pretty much type it as you see it. Parentheses, negative 22, close parentheses, and square it. And then we want to subtract 4 times 8 times 5. Make sure we got that right. Negative 22 squared minus 4 times 8 times 5. And you could either do the parentheses to multiply or a multiplication symbol. Since these guys aren't negative, I don't have to worry about the parentheses too much. But if you wanted to use an abundance of caution, then we would put those other numbers in parentheses too. Parentheses matter most for things like negative numbers and fractions. All right, so calculator says it's 324. So that's the inside of the square root. So now I have, oops, let's get a pencil. There we go. 22 plus or minus the square root of 324, all divided by 2 times 8, or 16. So next we have to do is see if we can figure out the square root. A couple of ways to do that. You could just try to take the square root. If it comes out to a weird decimal, then we'll have to back off for a moment. If it comes out to be a whole number, then cool, we're done. So square root of 324, close the parentheses. Well, look at that, whole number, 18. That makes my life easier. So now, let's see, we'll bring that up here. We've got x equals 22 plus or minus 18, because the square root of 324 is 18. Square root is now gone, divided by 16. So this means I have actually two answers. One is 22 plus 18 over 16, and the other one is 22 minus 18 over 16. So let's clean those up a little bit. 22 plus 18 would be 20, 30, 40 over 16. And that will probably reduce. Might as well reduce it now. Let's see. Does 16 go into 40? Not quite sure. Let's see. 8 goes into 45 times, and 8 goes into 16 2 times. All right, I shouldn't have put a comma there. That's actually equals, because I reduced it. So again, what I did was I divided 8 into the top and 8 into the bottom. And you should always write down what you do so you can verify that that's right. 8 goes into 45 times, 8 goes into 16 2 times, so I get 5 halves, which you could write as a decimal too. All right, the other one is 22 minus 18, which is 4 over 16. And then 4 goes into both of these, so I'll divide 4 into the top and 4 into the bottom. And that gives me 1/4. So I think I have two answers here. Let's circle them. I think this is one of them there, and I think that's the other one there for x. Next we have to check to make sure it's true, and sometimes checking's a bit more work, but calculators are pretty nice. So for a check, we rewrite the original equation with parentheses where an x was. And I'm hoping when I plug in a number, it works. So let's plug in the 5 halves first. So always write down what you're going to calculate before you calculate it, and then move over to your calculator. All right, calculator, we've got 8 times parentheses, 5 divided by 2, squared, minus 22 times parentheses, 5 divided by 2. So I'm just typing exactly as I see it. And then we have plus 5. Make sure we type that right. 8 times 5 halves squared minus 22 times 5 halves plus 5. 8 times 5 halves squared minus 22 times 5 halves plus 5 equals 0, which is what I was hoping it would be. So I used my calculator here. And my calculator said the above was 0, which matches the 0 on the other side, and so that's a check. We also have to check the other one. So to check the other one, repeat the process, but with that other number. So rewrite the whole thing with parentheses instead of an x. Question mark. This time we're going to plug in 1/4. And hope it works. So if you don't check, you just have an educated guess. You have no idea if you're right. So please find out if you're right. So 8 times parentheses 1/4, close parentheses, and square it, minus 22 times parentheses 1/4 for x, and then add the 5. Compare to your notes, make sure you typed it right, equals, ooh, either I didn't type it right or I have an error somewhere. I do have an error. I did times 2 up here instead of to the second power. So if it doesn't come out right, one of two things went wrong. Either you typed it wrong or you have the wrong number indeed. So if that's the mistake isn't in what I typed into the calculator, it's somewhere in my notes here. And so I would backtrack and try and find it. But I think I found the mistake in the way I typed it. So we'll try again. 8 times parentheses 1/4 raised to the power 2, that looks better, minus 22 times parentheses 1/4 plus 5. Okay, 8 times 1/4 squared minus 22 times 1/4 plus 5 looks better. And I got a 0 this time, which means I probably typed it right because I was hoping to get a 0. So again, in my notes here, I'm just going to say I used a calculator. Calculator says it's 0. Check. Cool. Next. So again, I just want to emphasize, what did I just do? I checked here. My answer is actually up above, right? So my answer for x is right there. Whoa, crazy pen. All right, so this time I have solve for x, x squared plus 6x equals 2. Now, you might be tempted to factor here, but factoring is useless unless there's a 0 on the other side, and that ain't 0. So first step is to get a pen and subtract that 2 over. So 2 minus 2 is 0 on the right side. On the left side, the negative 2 is not like the 6x, and it's not like the x squared, so the best I can do is say I have x squared plus 6x minus 2. Now, I could try and factor this. I could use the quadratic formula, or I could complete the square. We just used the quadratic formula, so let's try completing the square. Now, generally, my strategy is if it's a 1x squared, which I have a 1x squared, and I have an even middle term, so 6 is even, then I complete the square. If I have something other than a 1 out front, then I'm probably going to use the quadratic formula. So if there's a 1 and an even middle term, completing the square is pretty easy. Now, to complete the square, I actually want it the way it was before, so I'm going to put it back. So I have x squared, ooh, that's a funny square. Let's try that again. X squared plus 6x, leave a little space, equals, and there's a 2 on the other side. To complete the square, we identify that middle number. I'm going to call that b. So b equals 6. Then what I do is I take half of that. So it's b over 2. Well, 6 over 2 is 3. And then I take that b over 2 and I square it. So if I take 3 and square it, I get 9. And so 9 is the magic number that I am going to add to both sides here. So I'm going to write next plus 9 here and a plus 9 there. Once I do that, this side right here is now a perfect square trinomial, which means it factors as x plus 3 times x plus 3, or x plus 3 squared. So here's that 3 right there. Now that's equal to 9 plus 2 on the other side, or 11. And if you want, you could double check. So if I do like a middle check here, not my final check, oops, if I have x plus 3 squared, that's really x plus 3 times x3 x plus 3, excuse me. And when I multiply that out, I get x squared plus 3x plus another 3x plus 9. 3x plus 3x is 6x in the middle. And so you can see that this is indeed a perfect squared trinomial because it came from a squared binomial. Now the cool thing about doing that is now I'm ready to take the square root of both sides. Now square root of 11, that's not a good number. Well, it's not a bad number either, but it's not a perfect square, 11. So the best I can do is say, hey, that's the square root of 11. On the other side, I'm taking the square root of a square, which means I have to put a plus or a minus over there along with the square root of 11. And the square root and the square cancel, leaving x plus 3 all by itself. Last step is to subtract 3 to the right. Now, since the 3 isn't part of a square root, I cannot do anything to clean this up. And so the best I can say now is that x is equal to negative 3 plus or minus the square root of 11, which means I have two answers. One answer is negative 3 plus the square root of 11. It's not a very nice 11, is it? Let's try again. And the other answer is negative 3 minus the square root of 11. And we can check that, but we're really going to need a calculator. So let's go to a new page to check. Always go to the original equation to check. Oops, we're not ready for that problem. I guess I'm going to have to add a new page after. There we go. So my original equation was x squared plus 6x equals 2. And I want to check to see if x equals negative 3 plus the square root of 11 is truly an answer. So that means I have to put parentheses where there was an x, and I'm hoping it equals 2. And inside the parentheses, I'm going to put the negative 3 plus the square root of 11. And I'm going to ask my calculator, what is that? Could we do this without a calculator? The answer is yes. We did things like this in the last chapter. But I'm going to go for it with a calculator. If you're really curious about doing that without a calculator, give it a try or send me an email asking me to show that. So let's see, we've got parentheses, negative 3 plus the square root of 11. Now I need to close the parentheses for the square root, and I need to close the parentheses for the whole thing. And your calculator might be different. Every calculator is a little different. So your calculator may or may not have the parentheses after the square root of 11. But I need the parentheses around the sum, and then this is squared. And then I want to add to that 6 times, parentheses, negative 3 plus square root of 11. Close the parentheses for the square root, close the parentheses for the sum, hit enter. 2. Is 2 a good thing? Answer, yes, I wanted it to be 2, because that was on the other side of the equation. So my calculator says this is 2, and on the other side of the equation, I have a 2, which means this checks. So we should check again for the other one. Generally, these things with square roots do come in pairs. So if negative 3 plus the square root of 11 checks, negative 3 minus the square root of 11 should check, but I'm going to double check it anyway. So then we plug in using parentheses, negative 3 minus the square root of 11 plus 6 parentheses negative 3 minus the square root of 11. Does that really equal 2? Well, I don't know. It should if all my work is good. Calculator time. Parentheses, negative 3 minus this time square root of 11. On my calculator, I have to close the square root parentheses and close the parentheses for the difference. And then I can square it. And then I want to add to that parentheses, 6 times parentheses. Double check my notes, make sure, minus the square root of 11. Close the square root, close the difference, and I think I typed it right. Calculator says that is a 2. And according to my notes, that's a good thing. So on my calculator, I got a 2 The other side is a 2, so it does check. So my answers are indeed x equals negative 3 plus the square root of 11 is one of them, comma, sorry, x3, negative 3 minus the square root of 11 is the other one, and they both check. Okay, last problem. Complete the square. So we just did an example of completing the square to solve an equation. This time we're just completing the square to confirm I get a perfect square. So again, the process for the completing the square is to identify the term, the value by the x. In this case, it's a negative 14. So I'm going to make a note that b, my middle term, is negative 14. Then I want to take that b and cut it in half. So what is half of negative 14? Well, negative over positive is a negative. 2 goes into 14 7 times. Then we take that new number, our b over 2, and square it. So what is negative 7 squared? Well, that's negative 7 times negative 7, which is negative times a negative is a positive. 7 times 7 is 49. So then what I want to do is add a 49 here. And if I did that right, that should be equal to the square of x minus 7. That's it. How could I double check that that's right? Well, so my answer is right here in this new equation. My claim is that those two things are equal. So to check that, I just take the x minus 7 squared. Square means multiply something by itself. It's the parentheses that are squared, so I have to multiply the parentheses by themselves. Parentheses happens to have an x minus 7 inside. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is also negative 7x. And negative 7 times negative 7 is positive 49. Negative 7x's minus another 7x's is altogether negative 14x's. And I do indeed get what I said I did on the left up there. So it does check. So right here, I'm multiplying the square out. Completing the square is like factoring. It's a special way of factoring. All right, that's it for now. Thanks for playing. Have a good day. Do good math.